Good evening, friends. Study with the Pala Engineering and General Geology Parvin Singh book. So, in chapter 14, we study metamorphic rocks. So, mineralogical compositions already finished, and structures of metamorphic rocks today we read. Some of very common structure found in metamorphic rocks are discussed briefly. Just a bit. Some of a very common structure found in metamorphic rock are discussed briefly as follows. Cataclysmic structure. It is characterized by the development of extremely fine rock mass under the influence of severe crushings and shearings and effect of stress operating during metamorphism. The effect may be observed in rocks spread over wide areas, rock like crushed breccias, myelinite, and slates. So, these types of structure. Cystose structure. The rocks with the cystose structure is made up of broadly parallel or subparallel layers or bands of flaky, platy, and rod-like minerals, making it very weak in the directions of parallelism. Rocks named as cyst typically show these structures. Gneiss structures. In these structures, bands or folia of platy and flaky minerals alternate with those of equidimensional and granular minerals. And these bands are generally of contrasting colors, composition, and textures. The gneiss structure is indicative of an advanced degree of metamorphosis under combined actions of high temperature, high pressures, active participations of fluid. Structure of metamorphic rock. Cystose structure, mica cyst. Gneiss structures, banded gneiss. Maculose structure, hornflakes, and granulose structure, marble. Maculose structure, it is characterized by a spotted appearance of the rocks that may be caused due to the formation of large size crystals called the porphyroblast within and otherwise fine-grained rocks. This structure is a typical product of a thermal contact metamorphism and results generally due to incomplete recrystallization of the constituent minerals. Again, structure is broadly similar to maculose types and is typical of metamorphic rocks in which the effect of crushing under pressures are clearly associated with recrystallizations. In this structure, some resistant minerals get deformed into thin lenticular lens-like shapes and giving a characteristic appearance to the rock. Granulose structure. It is a typical structure of a metamorphic rock like marbles and quartzite and is characterized by an essentially granular character of the constituent minerals. The individual grains may be irregular in outlines but are interlocking. Interlocking foliations is absent or negligible. Rocks with granular structure are termed as granulites. Some of the above structures are developed on such a large scales in the metamorphic rocks that these becomes easily the most important distinguishing features of those rocks. These large scales structural features are then special referred as rock cleavage, cystosity, and foliation. Each term deserves a clarifying statement. Rock cleavage. It is an important and typical structure features of metamorphic rocks and may be defined as the capacity of the rocks to split along certain directions, yielding parallel or subparallel smooth surface. Two types of rock cleavage are distinguished theoretically. Flow cleavage. It is also called slate's cleavage because of its development in slate. This cleavage is developed during metamorphism by parallel arrangement of a highly cleavable flaky and platy minerals like mica, talc, and chlorides, which make the bulk of the original cells or clay. Sometimes this gives the appearance of bedding planes in the rocks, but actually in most cases it is developed cuttings across the bedding planes. The trace of bedding planes may be found as a relict structures in some slates. The slate's cleavage is the result of several types of dynamic metamorphism of clay and shells, fractures of cleavage. This types of cleavage is developed due to parallel orientation of a very fine fractures and so often called micro fractures that may be developed in minerals of rock undergoing dynamic metamorphism. It is often difficult to distinguish between two types of cleavage in hand specimens. The cleavage structure is of great importance in field mappings of metamorphic rocks as it provides very useful information about the structural features like folding. Cystosity. It is a structural features of many metamorphic rocks called schist and signifies that the rock is made up of parallels or subparallel bands or layers of platy and flaky minerals like mica, chlorite and tourmaline. It's within these bands may be found in enclosed grains or crystals of some other minerals like garnet and hornblende. Cystosity result due to combined effect of the heat and pressure during metamorphism involving both recrystallizations and reorientations of platy mineral as irregular layers or bands. In other words, this structure is the product of combined actions of thermal and dynamic metamorphism on a variety of rocks such as cells, rhyolites, granite, and basalt. Foliations. It is a broader term explains a layered structure in metamorphic rocks and is often understood to include cleavage and cystosity. However, foliations in particular express segregations of minerals. In an alternating manner, the granular minerals make one layers followed by another layers of flaky and or platy minerals, both downwards and upwards, and the structure is repeated in 3 dimensions. In the entire rock mass, it may be regarded as an advanced stage of dynamo-thermal metamorphism in which the rocks is further segregated into bands of alternating mineralogical composition. Foliation generally is a result due to dynamo-thermal metamorphism in coarse grained igneous rocks like granites and sandstones and metamorphic rock like schist. Classifications of metamorphic rock. Metamorphic rocks have been variously classified on the basis of texture, structure, degree of metamorphism, mineralogical composition, and made of origin itself. A very general twofold classification based on the presence or absence of layered structure or foliations as defined above is as follows. Foliated rocks. All metamorphic rocks are showing the development of a conspicuous parallelism in their mineralogical and structural constitution. Falling under the general terms, foliations are grouped together as a foliated rock. The parallelism indicating features include slaty, cleavage, cystosity, and its gneiss structure. Typical rock includes in this groups are slate, phyllite, schist, and gneiss of great variety. Non-foliated rocks included in this groups are also those metamorphic rocks characterized with the total or nearly total absence of foliations or parallelism of mineralogical constitutions. Typical example of non-foliated rocks are quartzite, hornfels, marbles, amphibolites, and soapstone. It's important metamorphic rock. Slate. Definition. Slate is an extremely fine-grained metamorphic rock characterized by a slaty cleavage, by virtue of which it can be readily split into thin sheets having parallel smooth surface. The slaty cleavage is due to parallel arrangement of platy and flaky minerals of the slate under the dominant stresses operating during the process of metamorphism. Composition. Mineralogically, slate is made up of very fine flaky of minerals, mica, chlorite, and microscopic grains of quartz, feldspar, oxides of iron, and many other minerals, all of which cannot be easily identified even under microscopes because of their fine grain size. Origin. Slate is the product of low-grade regional metamorphism of argillaceous rock like clay and cells. Clay and cells dynamo-thermal metamorphism. Slate. When slate is subjected to further actions of dynamothermal metamorphism, recrystallization lead to the development in number of size of some minerals, especially micas. Such metamorphic rocks with the conspicuous mica CS constituents and general slaty appearance are termed phylites. The phylites on further metamorphism change into rocks called cysts that show megascopically crystalline textures and foliated structure. Slate is used locally where available for construction purposes as roofings and paving materials only. Next, rock cyst. Definition: cysts are megascopically crystalline foliated metamorphic rock characterized by a typical cystose structure. The constituent flaky and platy minerals are mostly arranged in parallel or subparallel layer or bands. And structure cysts show wide variations in their texture and structures, and most varieties are coarsely crystalline in texture and exhibit a typical cystose structure. Microcrystalline cysts are also not uncommon, so quite a few types show lineations and porphyroblastic fabric compositions. Platy and rod-like aciculars minerals forms the bulk of most of the cyst. Micas, both muscovite and biotites, chlorite, hornblende, tremolites, actinolites, and kyanites are quite common. Constituents of most of the cyst quartz feldspar are comparatively rare but not altogether absent. Porphyroblast of granular minerals like sterolite, garnet, and andalusites make their appearance. A.M.I.E cyst. Varieties specific names are given to different types of cyst on the basis of a predominance of any one or more minerals. Thus, some commonly found cysts are muscovite cyst, biotite cyst, sericite cyst, tourmaline cyst. It is sometimes cysts are grouped into two categories on the basis of degree of metamorphosis as indicated by the presence of index mineral. Low-grade cysts formed under the condition of regional metamorphosis at low temperature. These retain minerals like albite, muscovite, and chlorite that are unstable at high temperature. Mica cyst, chlorite cyst, and talc cyst are a few examples from this group. High-grade cysts, these are formed under conditions of regional metamorphosis and are rich in minerals that are stable at high temperatures such as andalusites, cordierite, garnet, sterolite, and selimanite. It's a garnet cyst, cordierite cyst, and sterolite cyst are common examples. Origin: as mentioned above, slates and cysts are generally the product of dynamothermal metamorphosis of argillaceous sedimentary rocks like clay and salts. These indicate the final and stable stage in the metamorphism of cells, though the intervening stage of slate and phyllite. Cell metamorphism, slate metamorphism, phyllite metamorphism, and cyst make. So some cysts like chlorite cyst and talc cyst may also be formed from basic and ultra basic igneous rock respectively. Thank you. Please give positive reply. Thank you.